Hello, so in the last video I showed you a method how we can sort of start drawing onto games using an overlay hook, this time through that time through the game overlay renderer module, which is Steam's own way of creating like a DirectX overlay. They'll hook the DirectX device. This time we're going to do something a little bit different, and we're going to use a method called the dummy device method. So last time I was showcasing this function here, which hooks Steam's present function. This time there's not very much reverse engineering involved, it's just sort of knowledge over vtables and DirectX9, and it's in this function here, the create dummy device hook. And we're gonna talk about it now. So essentially within games or within languages or C++, a thing called vtables exist, and vtables are just virtual tables, and all a virtual table is an array of function pointers. So what does this actually mean? Basically, it's just a way for compilers to optimize and sort of store how functions should be called. It's called dynamic dispatch, and generally that's how it's going to work. It's going to store it in a vtable. Any compiler can do it differently, but that is just sort of how it works. It's not like a standard way of doing it, but that's just sort of how all of them do it. So generally, when there is an object created, as I'll show you, it's better giving you an example here, and I'm also going to be doing a specific video on just vtables to give you a much more better in-depth explanation. So if it is a bit confusing, don't worry, this is more of just a demonstration, see what you can do. Basically what I mean by vtables is when we have an object here in memory, so we've got a pointer, for instance our player, all these functions are going to be stored in an object, in an array 0x0, like that. So if we dereference that location, we're going to get a big long array of just any pointers that are in there. So for instance, if we go to this location where the player object is in memory, we're going to find at its first sort of structure is going to be these 3 pointers here. I'm going to show you that now. I'll drag up ReClass. I'll get up. .NET. So the tool I'm going to be using here is a tool called ReClass.net. ReClass exists in a non.NET version. I don't know if it was built in C#, the original version, but it's a little bit it still works. It just looks different, and I think this one's just a bit more stable. So this is sort of why people use it. Right, so launching this program, we can sort of see that I've just printed out. This is just more for a learning thing. So the address of our actual object in memory is this. So let's say we've reverse engineered and we've found like a local player pointer, things like that, and we want to go have a look and sort of see what's going on. So all we're going to do is attach to our process, and we're just going to have a look at this object. Now straight away, the good thing about ReClass, why this tool is so useful for looking at structures, because it represents a structure in 3 formats: decimal, hexadecimal, and then binary. So it just makes everything infinitely easier to sort of go through and just spot and see what things are. So for instance, here you can see that that's something through the vtable, and right here we can see that it's creating a heap allocation there. So we can assume this is some sort of large like data object store, like an array, things like that. So if we were to change the type to a vtable pointer, now remember this is the address of our object. So this is the player. This is this here. This is our player. And if we go to this first structure here, at these 3 locations will be functions. Now if we take it one step further, and if we just create a new class just for looking at things here, we will get an address of the vtable instead. So this is the vtable for that object, and we can see the first 3 parts of this structure. This is an array in memory, as you can see here. Pointer there, another pointer, and another pointer there, and we can see the pointers because look at the spacing, well, we can see that it tells us they're pointing. This is a good thing about ReClass. It tells us it's pointing to this location here. So if we went to this location in a tool like x64 debug, things like that, we'd be able to see where we're actually going. There we go. If we just pop this open again, so if we just took this address here, and a quick look, it'll tell us exactly where it's going. I can see straight away there. That's the first function of our vtable. So if we go back in here, first function, this will be our second function, create 1, create 2, create 3, etc, etc. And this is how you would basically reverse engineer and go through vtables. This is also sort of how you're going to find your functions within DirectX. So DirectX utilizes vtables, things like that, and a way in which we can hook these functions is through a dummy device method. Now, when you create a DirectX device, or in general when you use vtables, the objects are going to be different. So what we're going to do with the dummy device method, we're going to create our own device, and we're going to generate a vtable, and then we're going to copy the address of those functions. Now, you might think, oh, but it's a different object, so why is a different object going to tell us where the address of the functions are? That's because the vtables will all share the same sort of location in memory where the function are. So it's not going to create a new separate instance for that function. That'd just be inefficient. They're all going to point to the same place. The function's only defined once. But the object's going to be different, but the vtable is going to point to the exact same location. So all we can do is just create our dummy device, grab the addresses that we need from the vtable, and then we're going to hook the functions. Now you might be asking yourself, if you're familiar with vtables, why don't we just overwrite the function pointers? If all the vtable is just an array of function pointers, why don't we just overwrite that pointer and point to one of our own functions? That would work if we had the original Direct3D9 device. However, as it's our own object, it's going to be separate, so the vtable is going to be different, and it's only going to work for our object, which we're just going to destroy anyway. It's just not going to work unless we get the original object's pointer. So like if we reverse engineered the game or whatever, and we found the Direct3D device pointer, we would then be able to do pointer swapping through vtables, things like that, which is something I will demonstrate as well. But just for this, again, just for this video, it's a fairly short demonstration. So all we're going to be doing is creating our own DirectX9 device, which is pretty simple. So we need a few things for it. We need a handle to our window here. So that's all this is doing here. And we're just going to be I'm just going to basically following just any sort of game tutorial, things like that. But creating games or using this engine, this is just sort of how you do it. You create your initial interface that you're going to need to actually create a device. So once we've created our interface here, this is how you do it through the static version there. And then all we're going to do through our interface that we've just created, we're going to then create a device. So in our device, we're going to have to specify some parameters, and these will all be different. Just in my case, they are. This will work for my instance. So game's not windowed. There's the device handle, and these are some other settings. So for example, swap effect. You can put others in there as well. Again, play with these things. So sometimes they're not going to work. For instance, your device type and your adapter type, things like that, they might have to be different based on your specific needs or different games. That just comes with experience and just trial and error. So for instance, if it's not working in windowed mode, try it in non-windowed mode, things like that. And once we've created our device, we can then grab our vtable. So all we're doing here is just accessing, we're dereferencing the vtable pointer, which is the first sort of thing at our object. So this is the equivalent of doing this, basically. I prefer this. It's a little bit easy to read, but obviously it doesn't make sense. Well, it does, but yeah, it's just this is just the same thing, but it's a little bit easy to read, I think, if you're not familiar with vtables. But it's just never going to be written like that. Don't make sense to write it. And then what we're doing here is we are basically going through the array. So we've said, take us to our vtable, and then once we've got the location of our vtable, we're going to step through the array. And obviously the size of a pointer doesn't change based on your architecture. It's either going to be 4 or 8 bytes. So now we're saying we want to grab our function at a specified index, and the two functions that we want, or that I've just given for this example, being EndScene and present. That comes with experience, and you'd go through this and reverse engineer what functions you want. You have to find their index, or you have to find sort of where they're located in memory. we're lucky enough this time to have an SDK with us, so if we really wanted to, if we had no idea where these things were, but we sort of knew it was a vtable, we could actually just step through our vtable here, and if you count all along this, if we go to EndScene, you will see it is at index 42. If you really want to do that, I've been through it, done it. That's just how it works. So that's all we're doing there. And the reason why we're doing this, obviously, because I've just explained size of a pointer. So we're going to have to go through that 42 times, and that's where it's going to be located in memory. Same with present. Yeah. So this is just for our debug information. This is our vtable that we've created, and this is going to be the address of present in the module, and the same with EndScene. And then all we're going to do is insert a trampoline function from EndScene to our own hooked function. Now again, we can't just swap the vtable pointer because our object is different to the one the game's using, and we're not going to create our own and just use that for various reasons. It's inefficient. You can do that if you wanted to, but it just doesn't make sense. So what we're doing here is just doing a little cleanup, and then once it's hooked, we can interact with the game however we want. Also, a small change as well that I made from the last video, I didn't actually specify the calling convention on these functions. We'll still compile and it will work. However, when you try and call these together, it wouldn't work. So that's when I went back and just quickly made these changes just to explicitly specify that these are going to be standard calls. Otherwise, your compiler would probably put these to C decal because it's a C application, which I think it was doing anyway. Hence why it was giving me a stack issue. So now we're just going to show this function basically. So once we've inserted a trampoline, this is our EndScene hook here, and then we're going to execute the original function at the end of our EndScene hook. And for EndScene, I think it only takes one parameter, which it is going to be our Direct3D device. So let's go back here, just to reiterate again, creating our function prototype up here. So this is our as I mentioned last video as well, there's a few different ways you can sort of write function there's a few different ways you can do anything, but I prefer doing it this way. It's a little bit more explicit. So we're going to create a type for our function prototype. In this case, it's going to be handled to a result. That's going to be our calling convention, and we're just going to call it EndScene func. So it's nice and easily readable. And then here is where we're going to declare that our function prototypes. This will be a pointer to the original EndScene function. And then in our hook, we're then going to be executing that original function. So when the return instruction, basically all it's going to be is a jump. So this is why trampoline works. When you return something, you're going to jump to that address. Hence why we're putting the pointer to our function here, because it's going to go straight back there and execute this as if nothing ever happened. So just compile this, and then we'll give a demonstration. There we go. As you can see, one is green, one is red, representing our present and our EndScene functions. Sorry about that, I just had a quick little issue there. So basically, I was dragging it from a separate monitor. That's going to cause you issues unless you put in the correct things in place. Again, this is only just a quick example. So these sort of error checking and just other things that can cause problems when you're hooking these functions, other things that you need, like resetting your device and things like that. That's not implemented at the minute, hence why it crashed. But this just sort of shows yeah, your EndScene hook, and then obviously last time we showed the present hook through the Steam overlay. But yeah, just a nice little cool way of doing things. And we're going through in the next video more specifically the trampoline function, and we're going to reconstruct a trampoline function to do so basically you can achieve this kind of thing here, and we're going to talk through it. And the same with vtables as well. There'll be another separate video going through vtables very specifically, so it's not just a case of, oh, this is how you do this, going through why you're doing that. Yeah, thank you for watching, hope you enjoyed.